Everyone, we're going to go over the Leetcode daily problem for today, and it is a very, very hard one. It is, if you look on like the zero track ELO on the contest, like very few people were able to solve it. We're looking at a 2,600 ELO type of problem, which is the hardest problem that I've looked at and actually like understood a solution for and solved. I think this is actually the hardest one. And if you don't know me, I've like solved a lot of LeetCode problems. I'm 2000, so this one's a little bit above my pay grade. But we're gonna go into like the solution. So I was not able to do this problem, obviously, but I was able to read the solution, understand it, and then now I'm gonna make this video to kind of like just break this down. And in the future too, I think this will be easier for me because like if I ever see a problem like this, I'm gonna be completely good. So uh, also, this is again, this is a very hard problem. So unless you are really, really good at LeetCode stuff, like this is probably going to be too advanced. And I would recommend that I have a sliding window. This is a sliding window problem. I have a sliding window, like 20, 30-minute video for beginners. If you can just go watch that if you're a beginner. If not, you'll be confused because I'm not going to spend time explaining sliding window and then going up to there. So anyways, okay. So let's get into this. So I'm going to assume that you solved yesterday's LeetCode one, which is like the easier version of this, which is that like you have like some numbers k, and essentially like what we want to do is we want to grab all these elements here. So like six, k is six. We want to grab the first six elements, and we want to get the two biggest numbers, two most frequent numbers, right? Because x is two. So we have six, and we want to get the two most frequent, and we want to keep doing that. So we do it here, and we get six because two, one, and then four. If they're tied, you want to pick the bigger number. So we get four. Oh my gosh, it's two numbers. Sorry, one and two would be the case here. But we do we do four because we add up all the twos, and then we do ones because we add up all the ones, and so that gives you six, right? But like you keep doing this, right? So that is like what the problem is asking, is that like we want to do that, but then we also want to roll it down and also do it for this one here too. So the solution for this is like there is a brute force, right? So the part one of the problem is that like you would do this and it was fine to do brute force. The input size was only like I think 100 or something. I think it was like 100 or maybe 500 or something, but like you could just brute force it. So you could literally just, okay, well, let's just count these. Let's go ahead and count these and then get the biggest. Let's count these and get the top K biggest and just manually do it. Then what can we do? Like, how can we do better than just like grabbing this and like, oh, okay, well, we counted and then, oh, okay, well, we've been here counted. Like, so there's a couple of observations that we can make, right? So the first observation is that, okay, well, if we've already calculated this, we don't need to recalculate all of this stuff. We don't need to recount all of the numbers because we already know that we counted all the numbers like initially. We don't need to recount all the numbers when we go down just a list. We only need to recount one number, right? Which is the one that we kick out. And then there's another one or number here that we add. So this is a very, very big observation because we can actually save time on computation, on the logic that we're doing and all of that. The second observation here is that like we can use sliding window, and maybe that was actually probably even like at the beginning. Like once you see subarrays, you're probably thinking maybe sliding window can be used. As you should be. But okay, the second thing is we can actually sliding window this, right? So we can roll over, so we can go here, boom, boom. This is a very big observation. Now, the third observation, then the one that I missed for this, is that we can have multiple sliding windows. And this, I haven't actually seen, so again, out of like the 1,000 problems that I've done, I've very rarely seen multiple sliding windows as a solution in a problem. So I was thinking about this, how can I do this with one, maybe two sliding windows? But this problem actually uses three. Or at least there is a solution that uses three. I don't know, about any of the other, but there's a solution that uses three sliding windows, which I didn't think about. But so the first one is that, okay, so we have our answer, right? So like we have like six. We need six numbers here, or a set of six. Sorry, okay, a set of six in our array. Okay, right. So that's one window that we're going to be having, right? It's the six here. This is the obvious one that I kind of like just showed, and most people probably would see that. The second one is that we have another window here, which is this x. So we have these values, the top two, that we're going to be using. And then we also have the sum. So that's also going to be like the third window. And so what we can do is, right, if you're doing sliding window, okay, we've got options. What kind of window do we want to have, right? And then in this case, okay, well, we want a window that's going to be able to give us the biggest and the smallest. I think you could probably use a heap here, but what's even cleaner than using min and max heaps to keep track of like the smallest and the biggest frequencies, right? Because we want to keep a balance. We want to know which values are going to be there. Well, what we can do is instead we can use a sorted list in Python. Binary search tree, I think, if it's Java, C++, whatever that equivalent is, but sorted list in Python, that's going to allow us to just maintain, we can have two windows. So, right, so we have the 6 here, basically, effectively 6, right? I mean, really it's 4 because we don't want all of them, but we want to maintain them as two differences. So we have like the answer that we're going to be using, that we're looking for, which is really just the two biggest, right? So we have the x, okay, the biggest. Then we have like the smaller ones, right? Okay, so we have 4. We're gonna have 4 of those. Cool. So we're gonna have the window. It's gonna be a sorted list. Gonna maintain track. So the sorted list is gonna keep track of what's the one that's the biggest, which one's the smallest, and we can store those there. Cool. Great. Okay. Now. We're gonna, for the third window, we're gonna have the sum. So we're gonna have the actual final answer. So instead of computing it, we have all the top elements, sure, but instead of computing it every single time, we're just gonna have that value so that we can just pull it up immediately. And so honestly, I'm not sure even like if this really needs drawing, but like we can actually even draw this out, right? So actually, I don't know, because this is sliding window, I don't know if it actually needs to be drawn out. But like the idea here is that like, okay, if we have these 6 elements, right? So like I'll show you the algorithm. Maybe this is making more sense to you, but I'll show you the algorithm for this, or walk you through it. So we'll have a 1. Okay, so we're gonna add it, right? Which window should we add it in? We've got 3 windows, right? Which window should we add it in? Well, let's go ahead and add into the x because x is too small, right? We need 2 elements in our x. So the candidate's going to be like 1 is now our candidate for x, right? Okay, it's too small. We should add it there. Okay, then we see another 1. Which window we added in? Okay, obviously the one where the 1 is already there. Okay, cool. And we'll get into the actual code and like logic of like adding things, into the window. Like how do we even know like that we can remove? How do we know like what, like we could just literally check, right? So this is the cool part about the sorted list, which is actually, I guess, maybe why heap wouldn't work. We can use sorted list because sorted list will let us know in log n is 1, which heap is 1 inside of. Like, so when I add it here and I'm like, okay, well, I want to update it. Well, I can add it here or I can add it here. Like, how would I know which one? Well, it's here. The 1 is here. We place it in this bucket. We can check it and log in that it belongs to here. Cool. So then we add it. Okay, cool. Then we go into 2. 2 is okay, right? Like x is less than, like x, we still have space here, so we need more numbers in our front answer. So it's gonna go here. Doesn't matter. Okay, cool. Once again, we check where is it in this one or is it this one? Oh, it's in this one. Cool. And then we go to 3. We'll update its count. Okay, well, is 3 inside of here? No, it's not. Is in here? No, it's not. Okay, cool. Well, does 3 happen to be bigger than what's inside of here? Like any of the 2, right? So its frequency count is 1, right? So then, hopefully this makes sense. I don't know. I don't know if I'm just like talking. I feel like I'm talking kind of, right? Like I don't know. I don't understand. I don't think it makes sense for me to draw anything here because I'm just drawing like 2 buckets here. Like I could draw out all the elements and I could paint them out and all of that, but doesn't matter. Also, I should actually mention here too. Like I said it earlier. I couldn't solve this, so I'm literally just going with this person's thing. Although I don't think he is as verbose. At least he's not making a video. He's not explaining it kind of like how I am. So, I mean, I think there's a big creative kind of spin on what I'm transformational I'm doing. So, anyways, yeah, I don't think you need to have this actually drawn out. Maybe I'm wrong though. I don't know, but maybe I'll look at the video and I'll decide on that. But so We'll go to the 3, and then we're just gonna say, okay, is it here? Is it here? No, it's not. Okay, cool. Well, let's add it into here then, because by default, like we're just not, and we're just not going to. And then let's check. Okay, well, are there any elements that are in here, like in this like secondary candidate that exist, or that like should replace anything here? And like then we just replace them. And we can do that very, very quickly because we can just say, okay, hey, is 3 inside of it? No, okay. Should 3 be replacing the thing that's here? No? Okay, cool, it's fine. 4, okay, you should replace no. Okay, cool. So we have our answer. We have the third window too. Every time we add to the window, we add to the third window, which would be the sum. So we keep 6 here. And then we just kind of keep going, going, going. So I'm actually just going to go through the code here, which is also, this code is longer than most Leetcode problems that I've also done. But I'm also going to kind of compare to this person. So like I literally just added more comments to his code because I didn't understand really like some of the stuff that he was doing, like this one, like balance keeps top and red balance. This is a terrible comment, by the way, but again, his solution is very good. It's just nobody wants to actually break down and explain stuff, I think. So right, so we're gonna have 3 windows here. Actually, these are the 3 windows, and we're gonna go through them. So I think the first things that matter is that we're going to be adding things and then we're going to be removing things from our windows. Now this code is just a lot longer. Like normally when you add to a window, it's like maybe 1 line of code. Now this is going to be like 6 lines because we need to grab the old numbers. So we need to know what's the old frequency of the numbers that we've seen so far, right? What is extract it? Like we need to pull out what is like this frequency for this number that we've seen. If we haven't seen any number, let's make it 0, right? So if you're not using Python, you'd have to default value this to 0. Python does it automatically. If the number is inside the top one, right? So this is the top K, the answer that we want, then we're going to remove it from our windows, from both. Remove it from the sum window, remove it from here. Very, very easy. We call dot remove. And we remove it, right? So we remove from our windows. And then we add it up, increment the frequency, and update it, add the new one, and then we do balance. Very clear, right? Very, very clear. Very clear, right? The dot remove is a sorted list method, which is super nice. Again, in login, it can extract that value out, pull it out, because we're using tuples, like this works. This is, again, a very, very advanced Python stuff. It took me a while to actually learn that you can use tuples, that you can use sorted lists and things. And so if you don't understand those things, then it's probably going to be, this is going to be super confusing to you, because you need to use tuples, you need to use sorted list. And okay, cool. So so we have the adding. Hopefully that makes sense. We can add and remove from the sorted list. Then we can remove, from our windows. Remove from the windows is really what I call this. Add to the windows. So we check if it's in the if the window's in the top. Again, I'm going very fast over this because I'm getting kind of tired. But remove from the value from the windows. Check if it's there. If it is, remove it. If it's on the other one, then we remove it. No use in removing it if it doesn't exist, right? So we just want to check, log in, update the counts, remove the count, add the new candidates, right? So we're going to have a candidate bucket, candidate window, and then our top K window, which is going to be the actual answer, and then we're going to balance. In the end, we balance every time. What's the process of balancing? It means that we're going to be checking. One, we're going to check, okay, is there something that's inside this candidates and nothing, like not enough inside of our final answer? Like we need that in our top K. So then we just pop and add it to both windows. Okay, we need to remove it if the top is in excess. There's too many things inside of like the top, like we need to remove it to kick it out. Finally, if there's a value, if the highest value, because it's sorted list, we know what the max value is. We can just get it very, very quickly. If the max value is greater than like the top's value, okay, well, then let's swap them. So let's kick it out, get rid of it, pop, and flip them and add them. And then we're gonna remove them from the windows here. So they use like a little equation here, but like we're just gonna remove from the window and add to the window. Same thing here, remove from the window, add to the window, and we're just literally swapping them. And that's literally it. Like that's like the answer, right? That's the solution. And then you can just fill up your window, add, build up our window, add into this initial one. We have our answer already. we have our answer already, and then we can just do top sum, append the top sum, and then just kind of keep going throughout when we loop through here. So hopefully this makes sense. This makes sense to me. This is also, again, I don't think this problem is that hard. I think it's complicated because it uses a lot of Python techniques, and like the sorted list, like this tuples, like this idea of like using like frequency lists and hash maps. Like it's tossing in a ton of stuff, a lot of stuff that you learn in algorithms, but it's not too bad actually, not too bad. So again, I would have drawn stuff. I just don't think it's necessary. I think that like we kind of covered a lot of this, and this is the 2598 problem. I like, again, if you're a beginner, like none of this stuff's gonna make sense. Like you're not gonna know what a sorted list is. You probably don't know what a hash map is. You know, like these while loops and stuff. Like these are probably all really confusing to you. So this problem is it's really layering on and like stacking in on all of that stuff. But if you're able to understand this, I would say like you're very, very strong. Probably doing very well, I would imagine. But cool. That's my thoughts on this. So good luck. I'm gonna be solving these problems every single day. Here, where's the thing here? Where's the thing here? I'm gonna be solving these problems every single day. So I think we're gonna start up with another like maybe 60 days, 90 days or something in Leetcode. And I might make videos every day, but cool. That's all I got. Yeah, I'm happy to understand this, and I'm gonna solve it again in the next couple days, and we'll see how it kind of goes. But if you guys want to join my school group where I'm also showing stuff for me coding, you can feel free to join. I'll have it in the description. You can join. I have like you can ask me questions and stuff or whatever, and I respond. So see ya. Peace.